Hi students, this is Mr. Yao. In this lesson, we are going to learn another method to solve system equations, and that is called elimination. But before we get into it, let's still use the substitution method to solve this prior knowledge question. Here you go. Seems x is the letter that doesn't have a coefficient with it. The second one has a negative sign, so we might as well just use the first one to isolate that x. So this equation, when you try to get rid of the 2y, you're going to subtract 2y on both sides. So that x is by itself, we will get negative 2y minus 2. And as soon as you isolate it, that means for the other equation, wherever you see x, you are going to replace it with this negative 2y minus 2. But be careful, that one has a negative sign in the front. So we got a negative 2y minus 2 plus 4y equals negative 1. When there's just a negative sign in the front, is actually like acting like a negative 1. So you're actually distributing a negative 1. It's going to be a positive 2y. It's negative 1 times negative 2y is a positive 2y. Negative 1 times the negative 2 is a positive 2 plus 4y, which equals negative 1. Altogether, we will have 6y plus 2 equals negative 1. Subtract 2 on both sides. 6y equals negative 3. And that means my y is going to be negative 1/2. And as soon as we have that, we can now put it into the equation that we use to substitute. Okay, so now x equals, and this time we're still doing substitution, and just this time we're substituting the y with a negative 1/2. So x equals negative 2 times negative 1/2 minus 2. Negative 2 times negative 1/2 is a positive 1 minus 2, that is a negative 1. So we'll have a negative 1 comma negative 1/2. That is still the substitution method. Before we get into the other method, let's do a little bit of exploration. So here's some work from Diego. Diego is solving this system equation, 4x plus 3y equals 10, and negative 4x plus 5y equals 6. I'm going to ask you to pause here, look at his work, and answer this question 1 and 2. Hopefully you have had a look. Let's see what is happening. So for his work, he has the first equation copied down, second equation copied down. Then he has this plus sign, which means he's adding both equations. And when he's adding both equations, the 4x and the negative 4x becomes a 0. And then 3y plus 5y is an 8y. 10 plus 6 is a 16. And then you just have this 8y equals 16. Divide both sides by an 8, easily get y equals 2. And then 4x plus, well, now I can actually put it back into that equation, either one actually, but he put it back into the first equation. Wherever he sees y, he replaced it with a 2, so 3 times 2 equals 10. And then he just solved the equation for x. First part is make sense of his work and discuss in your groups, what did Diego do to solve the system? So as what we just said, he added the two equations, and the sum is an equation with only one variable, which is y. And that can easily be solved. He then substituted the y value into the first equation and solved for x. Is a pair of n values that Diego found actually a solution to the system. Well, the solution is a 1, 2. Well, let me actually put it there. It's 1, 2. And it's asking how you know if it actually works. It does work because when the values are substituted back to the equation in the system, they actually make the equations true. So if you put a 1 here and a 2 here, 4 times 1 is a 4, 3 times 2 is a 6, 4 plus 6 is a 10. That works. Negative 4 times a 1 is a negative 4. And then 5 times a 2 is a 10. Negative 4 plus 10 is a 6. That one also works. So that's how we know that this pair is actually correct. And then we have second question, does Diego's method work for solving these systems? No need to solve, but be prepared to explain or show your reasoning. Here they are. Well, the first one, you can see, if you actually add the two equations together, well, the y and the negative y will actually cancel each other out, so you are left with a 3x equals 15. So you have one variable, that for sure works. For the other one, if you choose to add them together, well, that's where you see a bit of issue. Is 16x plus 12y, that equals to 44. Well, you actually still have x and y instead of just having one variable. So that seems directly with Diego's method is not going to work. However, with a little twist, we can actually make it work. And that's also what we're going to learn today. So now let's get into it. What does it mean when we eliminate something? It actually means to get rid of it. So today we are actually going to learn a second method. So now let's actually try Diego's method. We're going to add the two equations together. And by the way, this is a question you just finished working in the prior knowledge. I'm going to add them together. X and negative x together is a 0. And then 2y and 4y together is a 6y. That equals to negative 3. Divide both sides by a 6. Y equals negative 1/2. There you go. And now I can just put it back into the first equation. X plus 2 times negative 1/2 equals negative 2. So it's x minus 1, that equals negative 2. Add both sides with a 1, x equals negative 1. See, the answer is still negative 1, negative 1/2. This process that we did, this method, is called the elimination method, which, as you can see, we eliminated the x. By adding the two equations together, we're left with just a y, and that's why it's called elimination method. We will use algebraic operations and with both equations to get rid of one of the variables. And in order to eliminate a variable, you need opposite coefficients. So for that B question above, well, we don't have opposite coefficients. However, we can create opposite coefficients. And that's also some example. There are some examples that we'll see how that works. Now let's get to the examples. First one, you can see you have a 3 and a negative 3, which means we can directly add them together. That's going to give you a 0. Then 5y plus a negative 10y is a negative 5y. That equals to, on the right side, a 25. That divide both sides by a negative 5. Y equals negative 5. Afterwards, I'm going to put it back into an equation because wherever I see y now, it's going to be replaced with a negative 5. So 3x plus 5 times negative 5 equals 2. So 3x minus 25 equals 2, which means 3x equals 27 by adding both sides with a 25. Divide both sides with a 3, x is 9. So final answer, 9, negative 5. There you go. That's example 1. Example 2. This is the B question we saw above. And our issue was, even though we see the 8x and the other 8x, they're not opposites. They're just the same. However, we can easily change one of them to be the opposite. So first thing we're going to do, instead of adding them together already, I'm going to multiply this equation, the whole thing, by a negative 1. Because whatever we do to the left, we're going to do it to the right. So we're actually multiplying every single thing by a negative 1. I will change the equation to be negative 8x minus y equals negative 7. And now we have this top equation and this new equation that we created. You see you have an 8x and a negative 8x. So this time I'm actually going to add them together. 8x and negative 8x is a 0. 11y minus y is a 10y. Then 37 plus a negative 7 is a 30. Divide both sides by a 10. Y equals 3. Now I can just put it back into an equation. Replace the y with a 3. 8x plus 11 times 3 equals 37. So 8x plus 33 equals 37. 8x equals 34. So x equals well, not 34, just 4, so x equals 1/2. Final answer, 1/2, comma 3. That is example 2. Moving on, example 3. Well, this time you can see, well, I do have opposite signs, but no numbers that are the same. However, you may easily realize 10 and 5 are actually related. So even though they're not the same number, I can easily change one of them to be the opposite of the other. So that's what I'm going to do. In order to change a 5 into a 10, I need to multiply it by 2, which means I'm going to multiply the whole equation by 2. That will change the second equation to 8x minus 10y equals negative 34. Again, you have to multiply every single thing by this 2 because you're changing the whole equation. Now you can see with this first equation and this third equation, you have a positive 10y and a negative 10y. So see, even though you don't have the same number, but if you have opposite signs, it's still going to be easily doable. Now I'm going to add the two equations. 3x plus 8x is 11x. Positive 10y and a negative 10y, that's just a 0. On the right side, negative 10 and negative 34, that is a negative 44. Divide both sides by 11. X equals a negative 4. Afterwards, I can just put it back into the equation. because I solved for x equals -4, so I can replace the x with -4. 3 times -4 plus 10y equals -10. So it's -12 plus 10y equals -10. Add both sides with a 12, 10y equals 2, so y equals 1/5. Final answer, -4, 1/5. And it's actually 2 over 10 simplifies to be 1/5. There you go. That's example 3. Moving on, example 4. It actually is similar. So you see you have x and -2y or -5y and 10. So you can either choose to get rid of the x or get rid of the y, either way. But since x is a smaller number, has some smaller number, I'm going to choose to change the x's, to get rid of the x's. So first, I'm going to multiply that equation by a +2, because x, I need it to be the opposite of a -2, which means I need that x to be a 2x, so I'm going to multiply by 2. That's going to give me a 2x minus 10y equals 22. Okay, now I can actually add the second equation and this new equation, because I have a -2x and a +2x. Add them together, we are actually going to get a 0, and then 10y minus 10y, well, that's another 0. On the right side, -12 plus 22 is a +10. So we actually got a 0 equals 10. Well, the question is, does 0 actually equal to 10? The answer is no, which means in that case, the equation is not right. It doesn't work. So that would be no solution. There you go. That is example 4. Moving on. Well, that is actually everything for this first lesson. Thank you.